talking about adding and subtracting rational expressions. So yesterday we did the multiplying and dividing. Multiplication and division is a lot easier because when you multiply and divide fractions, you never have to have common denominators. When you add and subtract, you have to have common denominators. So back when you guys first learned how to add and subtract fractions, if you guys had something like 1/2 plus 1/3, you guys could not just add straight across. You had to figure out a common denominator for 2 and 3. So like, what's a number that both 2 and 3 can become? Yeah, so you guys would have said, okay, well, I know they both can become 6. And to find a common denominator, your teacher probably told you the fastest way was just to multiply the two numbers together, right? So 2 times 3 would be 6. So that was like the fastest way to find a common denominator. It's not always going to be the least common, but in this case it was. What did I multiply 2 by to turn it into a 6?
3.
And whatever you multiplied the bottom by, didn't you have to multiply the top by?
Yes.
That's what you would have done. So then the top would have become 3. And then what did you multiply this 3 by to turn it into a 6? So we would have multiplied the top by 2, which would be 2. Then you could have added your numerators. So 3 plus 2, 5, and then you kept the denominator the same. That was the process you did in like 5th grade when you first learned how to add and subtract fractions. So now we're going to take that and we're going to apply it to what we've been doing with these rational expressions. Okay, so the steps are up here, okay? But sometimes these steps can be confusing when you're just trying to read through it. I always think it makes a lot more sense actually seeing it. Now, if your denominators are the same, which most of the time I'm not going to test you on that. If they're the same, that's way too simple. But if the denominators are the same, you just add or subtract your numerators and you keep the denominator the same, just like we did here. If these two were the same, we added the top and we kept the bottom the same. Okay, so the first two down here, are my denominators the same?
Yes.
Yeah, they are the same. So before I do anything else, let's talk about what our restriction would be. What number could x not be? Yeah, x would not be allowed to be -4 because it would make our denominators 0. Since they're already the same, we're going to just write this as one fraction. And all we have to do is add the two expressions up top. So we're adding x plus x, which is
X squared.
plus
2x.
2x, yep. And then -3 plus -2, -5. That right there is your final answer. Like I said, that one's a little too simple because all you guys had to do was combine like terms up top and then you were done. This next one, they already have the same denominator, so we're going to keep it x squared plus 1. Now let's talk about this silly restriction before we combine what's up top. So watch. I need you guys paying attention because this one's tricky. This one over here was pretty simple to do in our head because it's basically just the opposite of that number, right? But this is an x squared. We have to figure out what number could x be if we plugged it in here that would make the denominator 0. How would I solve that? I'd subtract 1, right? So we end up with x squared equals -1. How do you get rid of a squared? We take the, what?
You would divide it by the...
Not divide. What's the opposite of squaring something?
You break it.
The square root. So normally this is what we would do now. We would say, okay, let's take the square root of each side. Square roots can be positive or negative, so I always put the plus minus symbol there. You guys, what happens if you have a negative under the radical?
You just put,
It's the letter I, right? It's the letter I. The square root of -1, if you remember back to the last unit we did, that's your imaginary number, isn't it? Yeah, so there are actually no real number restrictions to this one. The only restriction we have is the imaginary number. That's not going to happen very often. This one was just like a special case. So I'm going to write no real number restrictions. It's just imaginary. I guess I could have written the whole word. Okay, now we still need to go back up here and figure out what goes up top. But here, do you guys see this? See this sign right here?
mm-hmm.
We don't like minus signs. We always do keep, change, change with minus, don't we?
Mm-hmm.
So I would keep these two the same. I would change this to plus, and whatever these two were, they're now going to become their opposite. What are they both going to become?
Negatives.
They're both going to become negatives. Now we can put everything together. So if we had 3x plus -6x, what is that? -3x. And then -4 plus -1. Try again.
-5.
-5.
Oh, sorry.
It's okay. Now, like I said, those two, they're real nice. I mean, because they were nice and easy since they already had a common denominator. The rest of these notes, nothing is going to have the same denominator. So we're going to learn how to find a common denominator. And I'm going to tell you right now, it's work. It can be a lot of work. So you guys need to make sure you're paying attention. I know there's not many of you, but this is not the time to start slacking off, you guys. It is only 4 weeks in. We still have 4 more weeks to go. And you guys are too close to the end to be slacking off right now. Unless you're just, wanting to take Algebra 2 with me again next term, I guess. Maybe you just don't want to leave my room. I don't know. Some of you might be in here another 8 weeks because you're choosing not to do your stuff when the rest of us are doing it. I don't know. Guess we'll find out. All right, so we've got 2 fractions here. Look at their denominators. Actually, every time you guys do one of these problems, don't even pay attention to what's up top. You just need to look at the bottom first. And you need to ask yourself, do those denominators have anything in common? No. So the fastest way to get a common denominator, what did we say before? Like when it was the 2 and the 3, what was the fastest way?
6.
What was the fastest way to turn it into the 6? We just did what with them?
Multiply them.
We just multiplied them together, right? Okay, so if I want to find a common denominator for these two, can't we just multiply them together? Yeah. So what's 8 times 5?
40.
40. And then what would happen with the n and the m when they just attach? So 40. I'm going to put m first. My common denominator is just multiplying the two of them together. And it's 40mn. So now watch what I do. Once I know my common denominator, I immediately do this. I show the denominator under both fractions. I just go ahead and do this ahead of time. Because now that we know what the denominator is, we need to go back and figure out, okay, what is our numerator going to be? I gotta move this. This is in my way. My common denominator was 40mn. Okay, so listen. I need you guys to tell me, what did I multiply the 8n by to become the 40mn?
Times 5.
The 5 what?
5m.
5m? And whatever you multiplied the bottom by, don't you have to multiply the top by? Uh-huh. Now listen, we are multiplying now. So 5 times 3 is 15. And what's m times m?
M squared.
M squared. Okay. Now the other fraction, what did we multiply the 5m by?
8.
The 8n. So if I multiplied that by 8n, I have to multiply the top by 8n. So what is 7 times 8?
42.
56. And then wouldn't the n just attach to it? Yeah, 56n. Now are we ready to combine them into one fraction? Because they have a common denominator, right? So we're going to write one fraction. The denominator stays the same. Tell me about the tops. Can I actually add the two top numerators together and get something different?
No.
Like, you can't add them together because they have different letters, right?
Mm-hmm.
So I would just write 15m squared plus 56n. You just write it as one numerator. You just don't want to write it as a separate fraction, like two separate fractions anymore. Now listen, there's 1, 2, 3 terms. If all 3 terms had an m, we could reduce an m, right? We could cut it out. If they all had n's, we could cut an n out. If 15, 56, and 40 all divided by 5, we could do that. But these two divide by 5, but that one doesn't. These two divide by 8, that one doesn't. These two have an m, that one doesn't. And these two have an m, but that one doesn't. So it is actually in simplest form right now. There's no reducing that needs done. Will you have to reduce sometimes? Of course. Now let's talk about the restrictions. M could not equal what? Since it's just a letter. It's not like m plus or minus anything, it's just m. So m cannot be...
Negative 15? 15?
No, this one. When it's a letter, it cannot be 0. And n could not be 0. The only time it's going to be the opposite number is if it had said m plus 5, because then it would be negative 5. Or if it said n minus 2, then it would be 2. If it's just a letter, it's just 0. Okay? That's your restriction. All right, next example. Focus on your denominators first. So I'm looking at those. Okay, so listen. I have no idea right now if these two have anything in common because this one is a quadratic and it has not been factored yet. I would have to factor this to see if it has an x plus 4 in common. Because if it does, we're only going to need to use the x plus 4 once in our common denominator. So anytime you guys have a denominator that is a quadratic or whatever, if it can be factored, you have to start with that. So let's factor x squared plus 3x minus 4. I'm going to just, this is just extra work, so you want to just put it somewhere kind of out of the way. Always factor your denominators. Do not ever factor numerators. We're just factoring denominators only. What are my two factors to give us -4 and +3?
1 and 3.
To make 4. 1 and 4. And the bigger number, which is the 4, has to match the bottom. So the 1 is your negative. Okay, so I want you to write those two sets of parentheses over here under the quadratic. And then I just want you to cross this out because we are not looking at that form of it anymore. So I think it's important to identify what your common denominator is. Okay, so I hope you guys are listening. All 5 of you. What piece do both denominators have in common? Okay, so look, the x plus 4 that they have in common, if they have it in common, they both have it, meaning you only have to use it one time. Okay, so I'm definitely going to include x plus 4 in my common denominator. Then whatever they don't have in common, we still have to use. So this x minus 1, we still have to include in our common denominator. So anything you see more than once, you only use once, and anything that you only see once, you're also going to use. Okay? Is that okay? I promise you, you're never going to have 3 different sets of parentheses. Like the most that you should have 2 different sets, okay? So they should always have 1 set in common. All right, now, I'm going to do what I did before. I'm going to take that common denominator and I'm going to go ahead and get this problem set up with my new denominator. So we said it was x plus 4 times x minus 1. X plus 4 times x minus 1. Now here's the good news. Ready for some good news? This fraction right here, this one, doesn't it already have these two in the denominator spot? So if my denominator did not change, will my numerator change? No. So we get to just bring down that x minus 3. It's nice when only one fraction has to change because it's less work. Will you sometimes have to change both? Yeah, I mean, we had to change them both up here, didn't we? So sometimes you'll have to, but sometimes you won't. Now this one over here had the x plus 4. What piece was it missing? It was missing the x minus 1, so don't we need to multiply the top by x minus 1? Okay, so look up top. This is just distributive property, correct? Okay, that one's not too bad. Now look.
So it's 2x squared?
Yeah, hang on. Before we write it down, look. If I had this times this, like a 2 by 2, I'd have to do a box problem. So you might even have to do like a box problem. This one we don't have to. Like if I had to multiply x minus 3 times x minus 1, I'd have to do that 2 by 2 box. We're going to do one. Don't worry. We'll get there. But I'm just saying, remember how we already had to do some extra work there? You might also have a box problem within this problem. So these problems, they're hard because it's taking like 3 or 4 different concepts you guys have done already this term and throwing it in the same problem. Okay? But yeah, you said it was 2x squared. And then 2x times negative 1. Negative 2. Yeah, don't forget that letter.
Wait, why are we doing that?
This, dear. Remember how you did that already? We had to do that too.
Oh, that's why I said it was 2x squared.
Yeah, 2x times x was 2x squared, but then 2x times 1, 2x. Yeah, and then Brittany, if you had accidentally just put -2, when you go to combine the top, you would have put that -2 with the -3. So you would have combined the wrong things, because this is actually supposed to combine with the x. So you got to be careful. You got to be careful when you're doing that distributing. All right, so we have our two separate fractions. They have the same denominator, so now we can go ahead and put it back together as just one fraction. And good news is it's already a plus sign, so we're just going to add the tops together. So I always put this one first. My highest exponent is the one I always put first. So I wrote 2x squared. Then we need to put together a negative 2x with a positive 1x. What's 1 plus negative 2? Negative 1. Yep, negative 1x. And then what happens with the -3? Does it have anything to pair up with?
No.
So we just stick it at the end. Just hang on. Before we go any further, let's talk about our restrictions, if there are any, which there are. What two numbers could x not equal based on your sets of parentheses on the bottom? -4 and +1? Okay, those are our restrictions. Now look, remember how earlier I said only factor denominators, right? So in the beginning, I flat out said, if there's a denominator that can be factored, you need to factor it. That's how we found our common denominator. You don't ever factor out the top, ever, until you get your final answer, okay? Because now, could the top be factored? I mean, could we try to use the asterisk up top to see if it matches one of these? Because like if I get two sets of parentheses and one of them's x plus 4, can't I cancel it out like we did yesterday? So we have to try it. So let's just see what happens. If I go over here and I make an asterisk for the top, 2 times -3 is -6. My -1 would go at the bottom, and both of these would be 2 x's. What two numbers multiply to give you -6, but add to give you -1? -3 and +2. Okay, so look at what this factors to. I have a 2x minus 3, and then what is this side reduced to over here? X plus 1. Does that match? Like, does anything up top match anything on the bottom?
Yes.
No. This is an x plus 1. This is an x minus 1.
Oh, I thought that was for my bad.
No, it's x plus 1. Mine's just running together because I had to squeeze it in there. This is 2x minus 3 times x plus 1, and then x plus 4 times x minus 1. Does anything match?
No.
No. So, unfortunately, nothing cancels out. So, like, I could have just stopped here and been done. I didn't really even have to factor out the top, but you kind of have to check it, because if it had factored out and one of them had been x minus 1, I would have had to cancel that out like we did yesterday.
So, when we factored it all and we did that, okay, if we did the asterisk at the end and first it was a like term, would it be?
Then I would have canceled it. I would have canceled out the x minus 1s, and I would have left my answer as 2x minus 3 over x plus 4.
Okay, so it did.
Yeah.
Gotcha.
But when I factored it, nothing matched. So if nothing matches, I could have just left it like this. Yeah, I mean, it's not wrong for you to leave it in factored form. Like, I could have left my final answer, this over here, but nothing nothing matched, so it didn't really matter which way I wrote it. All right, 2 more, and then it's practice time. This is definitely one of the hardest lessons we do because it requires so much work. It's not for the lazy, I can tell you that much. Not that any of you guys are lazy or anything. All right, so look at your 2 denominators. Will either one of them factor? You sure about that? Hello, I'm here. Do either one of these factor?
Yes.
Which one?
9 and 3 and 30 and 5.
No. Denominators only.
Yes, 9 and 3 going to 3. Never mind.
We have a quadratic right there. X squared minus 9. What kind of factoring can we use on that? Difference of squares. So does it factor? Yes. We can use difference of squares to factor x squared minus 9. Remember, take the square root of each. You'll have 2 almost matching sets of parentheses, but one will have a plus and one will have a minus. What is the square root of x squared? X. So each one starts with x. And what is the square root of 9? So each one ends with 3. Well, you know, it's difficult when you only have 5 people in a class and some people are sleeping or not paying attention. All right, so when I look at this denominator versus this denominator, talk to me about what they have in common. Okay, so both of them have an x plus 3, so we're going to use that as part of our denominator. So the piece that they have in common we say once, and then the piece that they don't have in common we use also. So our common denominator is going to be x plus 3 times x minus 3. Notice right away, doesn't this fraction right here already have that? So that's good. The first fraction stays the same again. Okay, so both fractions will now have this as their denominator. My first fraction stayed exactly the same, so I'm just bringing down its original numerator. But then we need to talk about this guy. This one's going to be the problem. Because it had the x plus 3, which means it was missing the x minus 3. And if we multiplied the bottom by x minus 3, we have to do the same thing up top, don't we? What do you see here? 2 terms times 2 terms. That is a box problem. Remember on the last one we just had to distribute. This one it is 2 by 2. So we get to go over here and make a fun little box where we get to think back to Algebra 1 when we multiplied 2 binomials together. This is just extra work here. What is x times x? X squared. What is x times 5?
5x.
And then negative 3 times x. And negative 3 times 5.
15.
Negative 15. Okay, so when we write our new numerator right here, we've got x squared We've got these two that we need to combine. What's a 5x minus 3x?
2.
A 2x. And then the minus 15 is hanging out by itself. Now we're ready to combine, right? We're going to turn this thing into just one fraction. Yeah, but I can do it when we write. Let's just go ahead and write it as one fraction, because we're not changing the denominator yet. Okay, what kind of problem is that? Which means we should probably do keep, change, and then see these three terms? They're all going to change. It's keep, change, change. So negative, negative, positive.
So we write 2x squared minus 30 and then
No, we're going to just combine them. 2x squared plus negative x squared is?
Negative 3.
No, this was a positive 2.
1.
Okay, so we have a 1x squared. Now look, then I go to my x term, so this one right here in the middle, negative 2x. It had nothing to pair up with, so that would just go on its own. But then you guys would have to pair up negative 30 and positive 15. Negative 15, yep. Negative 15. Okay, so now before I go any further, let me write my restrictions. Now that we have one fraction and we have the full denominator, what two numbers can x not equal?
positive 3,
And
negative 3.
negative 3 and positive 3. Okay, remember on the last problem, we ended up with a quadratic up here, and I said we really need to check to see if it factors, to see if it cancels something on the bottom.
Yes.
We need to do that again. I know there's not a lot of room because I wrote really big, but negative 15 and negative 2.
Negative 5
Negative 5 and
and 3.
positive 3. So this time when we factored it, did they have anything in common?
Plus 3.
Uh-huh. So wouldn't we have to do this and this? Yep. So this one actually reduces down to x minus 5 over x minus 3. That one's a lot of work. You had to do common denominator, box problem, keep, change, change. Then you had to do another asterisk. Then we had to cancel some stuff out. Lots of stuff in that one problem.
Is that minus or
Which one?
3?
This one down here? It's the minus because I canceled out the pluses. Yeah. So you just leave your x minus 3 on the bottom.
I don't feel strong on these.
Huh?
I don't feel strong.
No, this is, seriously, it's every term. This is not a new lesson. This is a lesson I have taught for the last 5 years. I mean, it's one of the ones I hate teaching. I mean, I don't mind it because I love math, right? But yeah, people always kind of struggle with it. It's probably the most work on any one problem you'll do in the whole term. So people do struggle with it. I get it. But nobody said Algebra 2 was going to be easy. Still here, trucking along. Okay, last problem. Look at our two denominators. This one, can that be factored at all? Nope. It doesn't even have an x squared, and they don't have anything in common. This one doesn't have an x squared, and these two terms don't have anything in common. So it's not difference of squares, it's not an asterisk, and it's not a GCF. So if these two have nothing in common, don't we just have to use them both? Because like up here, whatever one they had in common we used once, but the one they didn't have in common we had to use anyway. So if they don't have anything in common, you're just using both denominators multiplied together. That would make up your common denominator. You're just multiplying them together. Just like on the first problem when we did the 8m times 5n, they didn't have anything in common, so we just multiplied them together. That's what we're doing here. So 2x plus 5 times 5x minus 2 under both fractions. One numerator will be easier to change than the other one. One of them will be a box. One of them will be just straight out distributing. Okay. What did I have to multiply this one by? Like what piece was it missing? So isn't that what I'd have to multiply the top by? Okay, look up top. We've got 2 terms times 2 terms. What is that? Is that the distributor or the box? That right there is going to be the box problem. So wherever you want to draw the box for that, I'm gonna go over here, since it's that numerator anyway. So we have 5x minus 2 times 3x minus 2. Okay, what's 5x times 3x? 15 what? X squared. It's okay. 15x squared. Okay, now what is 3x times negative 2? Negative 6x. And then negative 2 times 5x? And negative 2 times negative 2 is? Positive 4. Watch that sign. Okay, so the 15x squared was by itself. These two together is a total of negative 16x, and then you have the plus 4. Okay, good. All right, now the other numerator, this one's not as bad. Look, this already had the 5x minus 2, so what piece was it missing? So then when we multiply the top by 2x plus 5, that's just one term times 2 terms. That's just distribute. That one's way easier. So 2 times 2x is 4x, and 2 times 5 is 10. This video felt like it was way longer than this. All right, so we've got our common denominator, so now we're going back to just one fraction. minus, it's a subtraction problem. What do I need to do?
Keep changing.
Okay, so these stay the same. This is your first change, and then everything in the second numerator changes. So negative, negative. Now go ahead and pair everything up. Does that 15x squared have anything to pair up with?
No.
Nope, that's by itself. Okay, then we have negative 16x with a negative 4x.
Negative 20.
Negative 20x, yep. And then positive 4 minus 10, negative 6. Now let me just give you a hint here. Can you guys look up here? 15 times, don't write this, 15 times negative 6 would be negative 90 and negative 20. If you guys right now looked at your factor sheet at the row of 90, you would never find a pair of numbers that would equal 20. Okay, so the top, you can't even factor the top. So nothing's going to cancel. The only thing we have left to do is figure out what would make this 0 and what would make this 0. Now it's not just x plus 5, so you can't just say it's negative 5. It is a 2x plus 5. So remember how, like, if I told you if it was more than a one-step equation, you should probably write it out and work it out? Mm-hmm. These are both 2 steps, so I would write those out. Because that's going to give us our restrictions, and they're both going to be fractions. Well, you're close. Yeah, because I would subtract 5 to get negative 5. And when we divide by 2, it's negative 5 halves. So x actually could not equal negative 5 halves. So when you solve that, just stick that diagonal line through it. That means not equal. That way I don't have to write them again. And then this one over here, I would add to, giving me 5x equals positive 2. And then we would divide by 5. Yep, so x could not equal 2/5. Yep, those are our 2 restrictions. Most of the time when you guys were doing them, the bottom was just like x plus or minus something, so those were a little bit easier to do. But if it's ever 2x, 3x, 5x, you have to work those out because they're going to be fraction answers. And that's the end of that lesson. Not too bad. 43 is just under 43 minutes. It would be shorter if I could get my cursor to move so I could stop this video. There we go.